Mark your diagram if you need to. Not wasting time, right? I only have 3 days. I'm not wasting time. I'm sure there's a reason why I picked this proof in particular, right? Not because, oh, this looks tough. Let me see if I can stump them. No, there's a reason, right? And I think hopefully you're catching on why. Look at the proof statement. A JP does not bisect. Oh, we're proving something does not bisect. Remember, this was called an indirect proof. All right, if I ask you to prove something is not happening, I'm asking you to do this proof indirectly. So let's go over the steps, what needs to happen. Second step after you're given is what's called your assumption. We're going to assume something's true and see where it leads us. Anybody remember what do we assume is true here? Bryson?
The proof statement.
Not just the proof statement, the opposite of the proof statement. That's our assumption. I look at the proof statement and I assume the opposite is true. So we're going to assume that JP bisects angle HJK. You go the opposite of the proof statement. Opposite of the proof statement. Nothing in the givens, the opposite of the proof statement. And now you can use that on the diagram too if you want to mark it up. Our goal, somewhere in our statements, we want to contradict one of the givens. Now, if you look, there's two givens. And there's one obvious one, I think, that we're going to contradict. P is not the midpoint by showing it is the midpoint. Somewhere, I don't know what step it's going to be, guys. I don't know what step, but somewhere in this statement, we're going to show that P is the midpoint. Okay, that's what we need. I need your help. I don't know what step it's going to be, but proving that P is a midpoint. And then we've contradicted that statement and we're good. All right, first thing I want from somebody, what's true now? If JP bisects that angle, what's true now? And this is, again, I'm not going to sugarcoat it. At this point in the year, we should know, boom, right away. All right, there shouldn't be a question, what, the sides or what? No. JP bisects angle HJK. What two angles have to be equal up here? Bailey, let's go.
HJP and PJK.
Okay, those two angles up there have to be equal. All right, if we're struggling with that, oh boy, I don't know what to do. I'm at a loss. So angle HJP congruent to angle KJP. Definition of bisects. Now let's just not keep writing down random stuff. It looks like you guys are going to have me do what here eventually? Look what's on that diagram. Eventually you're going to have me do what here? Just like we usually do in every proof, right? Prove what? Let's get the triangles congruent because we're almost there. I already have a pair of sides from the givens and the bisects right now. So where else can I go? JP reflexive, or is anybody else? We could have also said H congruent to K because what are they across from? There you go. Okay, so we could go two different ways. I'll take your first suggestion, JP equal to itself. Reflexive. All right, let's keep going. Now the triangles are congruent. I'm just going to need a method though. Triangle HJP congruent to triangle KJP. What's one of the 5 methods we have? Side angle side, yep. If anybody did H and K, that would be angle side angle. All right, great. You got the triangles congruent. Remember our goal. You got to get J to be a midpoint to contradict the given. Where am I going from here now? I want J to be a midpoint. So, all right, triangles are congruent. Great. You got some partial credit. How does that help me? Keep going. Cormac, go ahead. If the triangles are congruent, so are these sides now. HP and PK. HP congruent to PK. We call that what after the triangles are congruent? CPCTC. done. Oh, whoa! If those two are congruent, what's point P have to be now? That's got to be. That's a midpoint now, isn't it? All right. If HP and PK are equal, P's got to be a midpoint, and in our proof, that's a problem, but a good problem. P is the midpoint of HK. And we could just write definition of midpoint. That's what we wanted, but again, right? Look at our given. It said it. Our given said it was not a midpoint, and now we're saying that it is. That's a problem. We can't have both. All right, but again, what led us to P being the midpoint? Our assumption. So that's a false assumption. So right after we contradict our given, the proof is done. I just have to write my proof statement. All right, saying that I contradicted a given. So what is it? JP does not bisect. HJK. Anybody remember that last line in every indirect proof? What did we just do here? Our assumption, what? There you go. Assumption led to a contradiction. So we start out with the opposite of the proof statement, and we look to contradict one of the two givens. And you know which one you're going to contradict. It's very easy to decide which given. You always contradict the not given. Questions? I think there's one more indirect proof somewhere in one of those 7 reviews. Last night, I also posted to Classroom 3 extra reviews. I'm sure there's indirect proofs in there. And there's a reason why we're going. I'm taking time out of class to do one too. Expect it. Anything else before I start hopping into other questions that I know that pertain to the midterm? All right, let's go. Buckle up. I'm going to review number 5 now, please. Review number 5. And I'm actually going to start with number 4 today. All right, let's start with number 4. All right, so that angle's 100. What do I know about the other 2 angles? Before I do any addition to my diagram here, if that's an isosceles triangle, angle B is 100. What do I know about A and C? They're congruent, right? They're congruent. The vertex angle is the non-congruent angle. So I already know A and C are going to be congruent. And what am I drawing in? The bisectors. What am I doing to them when I'm going to draw them in then? Okay, ready? Here you go. Here's the bisector for A. What am I doing to angle A then? Bisector. Okay, what's that mean? Splitting it, cutting it in. Whatever that angle measure is for A, I just cut it in half. And I'm doing the same thing for C, drawing in the bisector and cutting it in half. It tells us that they meet. They all intersect at point D. All right, what's angle ADC now? How do I find ADC if I start with the 100? All right. Anybody find angle A and angle C before I do anything here? What's angle A and angle C? Stella? 40 apiece, because 180 minus 100 divided by 2. 40, 40. And what did we just say we did to those angles? Cut them in half, right? We cut them in half. So each one here has got to be 20 and 20. And now can we find angle ADC? I hope so. Because I have 2 out of 3 angles in a triangle. 180 minus those 2 20s. And that should give me 140. So vocabulary, right? Vocabulary, bisectors. Speaking of vocabulary, number 6. Speaking of vocabulary, let's look at 6. we have AX is congruent or equal to BX. It's congruent to CX. What's point X called? What is point X called? So we'll go through all of these again. All right, so look, X is what? The same distance from A as it is from B as it is from C. Which one of those 4 points up there were all the same distance from, looks like the vertices of the triangle? That's what we have to figure out here. Which one of those 4 was the same distance away from the vertices? Going? That's why we review, right? You got a thought, Dylan?
The circumstance.
Circumcenter. The circumcenter is equal distant away from the vertices. Yes. Let's go over all of them now. The incenter is equal distant from the, not the vertices, but sides of a triangle. Centroid, not equidistant from anything. What was the fact about centroid? Breaks the median up into 2-to-1 ratio. One piece is double the other. And then orthocenter, there's nothing special about it. The only thing you have to remember about orthocenter, it's formed by the 3, where the 3 what intersect for orthocenter? Altitudes, yes, where the 3 altitudes intersect, yes. All right. 7. We go right from vocabulary to your quadrilateral properties. Great problem here, number 7. Great problem. Let's see how many of you fall into the trap here. Not yet, anyway, but. So think about everything you know about a rhombus right now. They give me the lengths of the diagonals, and I need to find the perimeter of ABC. All right, just start, even if it's not going to help us, I don't care. Start spitting some facts about a rhombus that you think you know, or hopefully they'll know by Tuesday. Rhombus, there's a lot here. Okay, diagonals bisect each other because it's a parallelogram too. So AC is 4. That means AE is going to be 2, and so will EC. Yes. BD is 6. So DE will be 3, and EB will be 3. All right, good, good. Let's keep spitting facts more. Because right now, I only know one side of the triangle ABC. I need to find the others here. What other facts are going to help me? Yeah. Yeah, all sides are congruent. So let me just, we're going to have to find, it says find the perimeter of triangle ABC. That's one right here. Notice I already know one side's 4, but what do I know about the other 2 sides at least? I don't need to know their measure, but what did we just say? All sides congruent. So those are going to be congruent. Once I find one, I know the other. All right, we're getting there. I just don't know how to find those sides. More facts. I'm waiting for one big one that's going to make this thing explode now. Dylan? In a rhombus, the diagonals are perpendicular. Yes. Now, why does this problem just explode? How can I find AB now? You'll be given that formula. I don't know if you'll need it, but yes, we can do Pythagorean theorem on triangle AEB. A squared plus B squared equals C squared. I'm going to take my time here because let me tell you, some of you guys have some crazy algebra when it comes to solving Pythagorean theorem. Crazy. All right. Where do the 2 and 3 go? A and B. Those are the 2 sides that make up the right angle. 2 squared, 3 squared equals C squared. All right, lock in here because some of you guys want to go crazy with your square root and you're not ready yet. All right, 2 squared. Got to square them. Got to square them. Got to add them together. Got to add them together, 2. Once it's all added together, now you can take the square root of both sides. All right, once it's added together, you can take the square root of both sides. If it's possible, your calculator will simplify it. Now, you guys are doing radical 13, and what's it giving you back? Radical, well, I don't care about the decimal because it's at simplest radical form. It's giving you radical 13 back, so you can't do anything. So this side is radical 13. The other side is radical 13. Sides in a rhombus are congruent. And now can we find the perimeter? What are my three sides I need to add up? Radical 13 plus radical 13. And what's that third side? 4. And look, your calculator does it for you. Just let it, it'll do simplest radical form right there. And it tells you the perimeter is 2 radical 13 or 4. Whatever, it doesn't matter which one comes first, but that's an awesome problem right there. Had to know your rhombus properties, and then to use Pythagorean theorem there. Anything? All right, what I got? One more? Yep. Oh, nope, 2 more. Sorry. 11. There's a vocab word, medians. Intersect at C. Okay, CE is 5. Y is XZ 15 here. YF is 21. Just be careful of the perimeter they're asking for here. Perimeter of CFX. So I got to find that perimeter. All right, these are all medians. These are all medians. What's a median again? Starts at a vertex. Where's it go? Midpoint of the opposite side. So everyone sees how XZ is 15. What's that one side XF going to be then? If medians go to midpoints? 7.5. So we have this side down, 7.5, because medians go to midpoints. All right, now the big topic. All those medians are intersecting at C. I do not come out and say this vocab word, but we have to understand what it is. Anybody got a name for C for me? Point C, if all the medians intersect there? Centroid. Yeah, that's huge because we talked a couple minutes ago. What's the centroid break a median up into? 2 to 1. So everyone sees CE is 5. What's got to be XC then? 10. Got to know that's a centroid though. All right, how about CF though? They told me YF was 21. The whole thing was 21. But remember, you know that YC has to be double FC, and they have to add to 21. Right? This YC has to be twice the length of FC, and they have to add up to 21. So we could guess and check numbers, right, that are double each other and add up to 21, and you might hit it. All right, a lot of you guys are good enough. You'll hit those 2 numbers. If not, if you're struggling to hit those 2 numbers, call the smaller one X. So what can I call the bigger one now? Double it, 2X. And you can say those 2 add to, what's the whole length? 21. If you can't guess and check those numbers. So that side is, the numbers were 7 and 14 we were looking for. All right, 7 and 14. So that side was 7, and then, yep, we can now find the perimeter. Good centroid question right there. And what are we looking, 24 and a half? All right. All right, we got one more here before I'm done for the day. Number 12. Number 12, go ahead and graph it. Yeah.
I need like guidance for the problem.
Yep.
Does that mean like equilateral? Or
No, it's like this is equal sides of 10. Now they have equal sides of 16.
Oh,
So where you see the 10, your new triangle has 16.
Okay.
Okay. Alrighty, we got them graphed. Part A, B, and C. Love all three parts here because we're going to need three different formulas. All right, prove the diagonals bisect each other. All right, which means they cut each other in half. I don't want to mess up your diagram. Let me mess up mine. So when I draw in diagonal AB and when I draw in diagonal DB, what's it mean if they bisect each other? They cut each other into two equal parts. So these two would be equal, everyone agrees? And also those two. Now look where they intersect. Right here. What's that point right there on AC? That's the what of AC. If both these are equal, that's got to be your midpoint. And what's the point on DB? Midpoint. So if these two do bisect each other, they should have the same midpoint. So we need the midpoint formula for part A. First thing you're going to do, find the midpoint of one diagonal, then find the midpoint, of the other diagonal. Are they equal? If they are, they bisect each other. All right, so midpoint formula first. Oh boy, I'll give it to you one last time. All right, we talked yesterday. You got to know this one going into Thursday or Tuesday. So we're going to find the midpoint of each diagonal, and they should come out to be the same if they bisect each other. So good practice on using that formula. Zero and 5.5. Hopefully you're getting out. Keep going though. Keep going if you're finishing up. Any issues there before we move on? Okay, part B. Show AD and BC have the same lengths in simplest radical form. What formula we're going to need now? Distance formula, yes. All right, so one last time giving you that formula. Square root. The order of your x's does not matter what you subtract, and the order of the y's do not matter when you subtract. All you need to do is plug in your numbers and let your calculator do the work. Plug in your numbers, let the calculator do the work. So show me that AD and BC in simplest radical form are the same. Don't drop negative signs, right? First, if you're doing AD, look at those X's, -3 and -6. So it should be -3 minus a -6. Don't drop the signs. If you want to put plus, that's fine too, but don't drop the signs if you're keeping them. BC. Hopefully when you plug it in, your calculator's giving you 3 radicals too. Yep.
For a question like this, where we have to like write a sentence.
Yeah, probably write a little statement underneath saying, hey, they're equal because the distances are equal, or they bisect each other because the midpoints are equal. Yeah. Okay, 3 radical 2. How are you going plugging that in? All right, you keep doing that. I'm going to go on to part C. So if anybody's ready for part C, this is why I love this problem. Now prove to me those lines are parallel. What formula are you going to need now? Slope. We need it all to the big 3 for all of it. Yep, we need slope. And remember, you have 2 options for slope, especially in this problem. You guys can do the change in y over change in x. Or because it's already graphed, we could use rise over run. Okay, so show me A, B, and DC have the same slopes. Either way, by either method. Thanks, Drew. Four nines? Did I count that right? And they're positive, right? AB, yep, going uphill. All right, questions there? Love this problem. You had to use all 3 there. Had to use the big 3. All right, I'm not going to tell you what. Look, we got a midterm Tuesday. You prepare how you got to prepare. I'm not going to say finish this midterm review. You have 7 of them right there and 3 more up on Classroom. I'm going to work on getting the answer keys to those, but the questions are up there ready to go. All right, so if you're coming in tomorrow, I'll see you then. If not, I'll see you guys on Monday. You guys do what you need to do to prepare. Tuesday's going to come quick.